Imagine you are standing on a giant floor map of a city. Your job is simple. You have 12 houses that need pizza and 4 delivery drivers. Each driver can only carry 3 pizzas at a time. All you have to do is figure out who delivers to which house and in what exact order. It sounds like a quick puzzle, but the math explodes almost immediately. For just those 12 houses and 4 drivers, there are more possible route combinations than there are atoms in the observable universe. No computer on Earth can try them all. Standard classical computers handle this impossible math by taking shortcuts. They make highly educated guesses and hope for a good enough answer. But for massive delivery companies running thousands of trucks, settling for good enough wastes time and fuel, costing them billions of dollars every year. To actually solve this, we have to look past standard computers and turn to quantum bits, or qubits. Qubits are the building blocks of quantum computers, and they process information in a completely different way. A standard computer bit checks one single route at a time. It walks down one path, hits a dead end, and starts over. A qubit acts like a ghost, exploring millions of possible routes simultaneously. To find the best path, QAOA acts like a specialized lens, focusing all those blurry possibilities down until only the single most efficient route remains. But there is a catch. To process all 12 houses at once, a quantum computer needs over 100 qubits. Today's quantum systems simply aren't large enough to handle that. If you try to run that calculation, the system hits a wall and completely crashes. This is where Meridian takes a different approach. Instead of throwing that entire massive problem at the quantum computer and watching it break, Meridian actively shrinks the puzzle first. It starts by using a standard classical computer to look at the big picture. It analyzes the map of the 12 houses and groups them by their general direction. The houses to the north go to driver 1, the east to driver 2, and so on. By doing this, the system zooms in on one dedicated zone at a time. Now, instead of one giant 12-house puzzle, we have 4 isolated pockets of just 3 houses each. The math just got 4 times smaller. Now, Meridian feeds just one perfectly isolated 3-house route to the quantum computer. Because the problem is so small, the quantum system can easily find the absolute perfect delivery order for those specific stops. Running a 3-house route only takes 16 qubits. That is well within the limits of what current quantum hardware can handle effortlessly, with no risk of crashing. Meridian repeats this process for the other drivers, and then stitches those 4 perfectly optimized mini-routes back together to form one flawless master solution for the entire city. This layered strategy, letting the classical computer organize the map, while the quantum computer tackles the high-speed math, is what makes the system so effective. It allows us to solve massive puzzles, using the technology we have right now. This chart shows a major issue with how quantum computers operate. They don't actually give you one single, guaranteed answer. Instead, they give you a spread of many possible answers. In this case, it is 68% confident in its top choice. Most systems just take that top choice and hope it's right. Meridian uses a tool called the glass box. Instead of blindly trusting the top result, Glassbox looks at the entire spread of probabilities and compares the 68% option against the secondary choices. The system logs every decision. It provides the final route alongside a clear explanation, showing exactly why that path is superior to the second best option using verified mathematical proof. Transparency isn't the only safeguard. Meridian constantly monitors its own health using a built-in AI watchdog. As the quantum circuits run, this guardian layer watches the complexity of the math in real time. If those circuits get too deep, the system automatically simplifies them. If it gets totally stuck, the AI can invent a new algorithm on the fly. And if even that doesn't work, it falls back on 5 sequential contingency plans, one after the other. These layers of deep verification and safety are crucial. They take quantum computing out from the fragile environment of a science lab and turn it into a reliable, professional system that always delivers a solution. We started with a giant map of pizza deliveries, but that was really just a metaphor for any complex logistical puzzle with too many moving parts. The exact same mathematical system that routes drivers can figure out which specific drug compounds should be tested first for cancer treatments. It can calculate the orbit and positioning of a satellite high above the Earth, or sift through millions of variables to build optimized financial portfolios, or perfectly schedule the arrival and departure of every single flight at a massive international airport. Many current approaches to quantum computing try to build a single tool for a single problem. When they run into the hardest, most complex variations of those problems, they inevitably run out of computing power and fail. Meridian operates differently. It is a complete operating system for optimization. You can hand it any complex problem and it adapts. It figures out the best way to process it, proves its own work, and learns from every single run to get smarter over time. By combining classical reliability with quantum speed and layering in deep fail-safes, Meridian establishes the practical foundation needed to actually use quantum computers for the world's most difficult problems.